For this part, we will map this flowchart to a program in the language C language. Okay, so let's get there. So this is the flowchart where we left off last time. So we needed to enter a grade as a numerical value of type float, and then evaluate the grade. Initially, the outer if statement, or the first one, evaluated if we were within the valid range, which means the grade was greater than 0 and less than or equal to 100. Okay, greater or equal to 0, less or equal to 100. Then we can proceed, and that will go into the true branch of this if statement. False branch of that same if statement will happen if the grade was less than 0, right, a negative value, or greater than 100. Okay, so 100.1 will lead us to a false. That will lead to an output that will print an error message that says grade out of range. Okay, so only grades between 0 and 100 will be accepted. So after that, we will evaluate based on the range. If the grade is greater or equal to 90, then we're between 90 and 100. So the letter grade will be A. And that will be the true branch of this if statement. Else, that means the grade was not greater or equal to 90. However, we know it's between 0 and 100 since we're in the true branch of the main if statement. So now we're at this scenario, and we're asking ourselves, is the grade greater or equal to 80? If it is, then you will print a B. And if it is, and indeed it was a B, notice you will go out down this way and you will simply exit. So you will not execute any of the other nested if statements. So that's the advantage of a nested if statement, is once you find a true branch, then you exit. Notice the flow, with the flow lines, okay? And the alternate statements that are sitting here will not be executed, which is a very efficient way to process the logic for a conditional program. So we're going to be writing code to map out to this. All right, so let's get started. So here's our file, and we're going to write this from scratch. So I'm going to need to write this in C for now, and that would be IOStream. Now I've already saved this file. I'm sorry, stdio.h. I've already saved this file as a .c extension. Okay, so it's already a .c. So if I click here and say file save as, you could see that it's asking me for something else. I'm going to say .c, and here's grade version 2.c. It's already a .c file. Okay, very important at this stage. Next, I'm going to have my main function, and that is what we call the controlling function. And now, system pause, it's okay if you're in a Windows environment, so be careful with that one. So that just simply will hold the screen. This may not work if you're doing this in Linux or on a Mac, or an OS that is other than Windows. Return 0, and there we have it. So we're going to follow the flow chart. So the first thing I'm going to do, according to the flow chart, is to go ahead and declare a grade of type float. So we're going to be doing that just right here. So float. So let me just write a comment. So we're going to be declare a grade of type float, right? So it's a real number. Okay, so that's what we want to do. So that would be float grade. Okay. Next, we're going to ask the user to enter a value for grade, right? So right here, if you see my mouse highlighting these two areas, that's where we're going to be doing now. So as you can see, I am going sequentially as indicated by the flow chart. Okay. All right, so let's go back to here, and I'm going to input a value for grade. Okay, and that would be two statements. Since you're going to do this at runtime, so you're going to ask the user to enter a grade. between 0 and 100. So you may want to help them understand this is what you should be entering. Okay, and then we're going to do a scanf. So this is the second IO statement as per flowchart right here, the second one here. That is where we're asking the user, we've asked the user to enter a grade. Now we're actually putting it in memory. Okay, so with the function scanf, %f, and %, so store it at that memory location. Good. So now we're ready to do our evaluation. Okay, evaluate the grade by using nested if statements. Okay, so what are we evaluating? We're evaluating what range it is. Is it between 90 and 100? Is it between 80 and 90? Is it between 70 and 80? Is it between 60 and 70? Is it below 60? Okay, so this is where we get to evaluate. So we're going to now write the outer loop. This is the technique here. So you're going to write the outer loop, which is the first one. And what I'm going to do, I'm going to show you slowly how to set it up by making sure that you complete the code for the else part of it and then test it out this way, okay? All right, so we're going to go back to our code here, and we're going to say something like this. If. Now remember, the if statement here is based on two conditions. One, you want to make sure that the grade is greater or equal to 0. So we're going to put that between these two parentheses and another condition. So I have two conditions going on here. This one and this one, A and B. A, I want grade greater or equal to 0. Okay, so that's your first condition. And so this is the and operator in C. You're going to say is grade less or equal to 100. Both of these have to be true to, so I'm going to put curly braces here for my true part. Both of these have to be true to say something like, yeah, great. So I'm just going to do a dummy printf right now. Let me just move this a little bit to the side here. Right there. Printf grade within range. Okay, so we can do something like this just for giggles right now to see how it works, right? So I can do this right now. Let's go ahead and compile and test it. So compile and run. And let's see what I did here. And it's saying, my /n is on the other side of my quotes. Okay, so it's good that I make mistakes like this so you get to experience that and not do it, right? So compile and run. There you go. And it's going to say enter a grade between 0 and 100. So let's say I put 55.8. Now remember, it's a float number, so you can do that. And it says grade within range. Let me run it again. Okay, so this is a good review for how a simple if statement works with a couple conditions to be true. So let me put a -4, and notice it will do nothing, right? So there is no else for this if statement. So can we put an else? Yes, absolutely. We're going to do one where we're going to print that the grade is out of range. Let's go ahead and try it for over 100. So I'm going to just put 101, right? 0.2, it doesn't matter. Right there, so nothing happens. So I would like to have an else statement here. And then printf. Now, since this printf here is a single statement, not a problem, no curly braces needed. And then I can do something like grade. Hey, let's enter that grade, %.1f, which means that 1 decimal point is not a valid or is invalid. Okay, and we could do something like this, /n, and then put the grade. Right, so that's the error message. It's out of range, it's invalid. All right, well, let's see how it works. So let's do that first. Compile and run. Okay, and I'm going to put an invalid grade, -1. There you go. Grade -1.0 is invalid. Okay, let's put another one and run again. And we're going to enter this time 200. Obviously, it's out of range. So grade 200 is invalid. So this is more useful because it brings back the grade that you've entered, just to make sure that the user knows, hey, you need to rerun this program. Okay, good. Now, we don't need the grade within range print statement here. We want to evaluate the grade now that we're within the right range. So what does that mean? That means we're going to be doing all of these if statements, these nested if statements that you're seeing on the true branch of the outer one. We've taken care of the outer one. As a matter of fact, the outer one ends there, right? So it ends, this will be your last statements for the outer if statement. So there's no more code below this other than the system pause function. So all the work is going to be right here, what I'm highlighting. So I'm going to take this off, and I'm going to put my first if statement. If grade is greater or equal to 90. Actually, truthfully, you should be writing it like this. So let me put 0.0 to indicate that you are comparing to floats. Okay? This is really how you should do it. Now, if that is true, then printf, you can print the letter grade A. Now, you could do something like this, A/n, and let's see if that would work, right? So we could do something like this, and this will detect that you indeed have an A in case you enter anything between 90 and 100. Let's test it out real quick. So notice here I just have an if statement without an else, but it will work only if the grade is greater than or equal to 90. So let's go ahead and compile and run. And let's go ahead and put 99.5, right? So notice here you get an A. Okay. Now, is there a better way also to do this? If you wanted to have fun, you could do something like this also. You could say %C, it's a character, /n, and then you could put the letter grade A as a variable on that print statement. This will do exactly the same thing. So compile and run. Okay. And let's say we had a 95. Okay. Fine. It's going to give us the same result. So this is an alternate way to do that printf if you wanted to print the actual character as a variable. Or let's go ahead and enter now a grade that is not in that range, but is valid range. So like 78, well, nothing happens. But we don't get the error message because it is a valid grade. Except we haven't taken care of the case in which we can manage and print a C because you got a 78. We're going to get there. So now, what do? Well, notice the flow chart here. We're right here. We've taken care of the true branch. Now we're going to go for the false branch. For the false branch, it's going to be an else statement for that if statement. And this is why we indent our code to make sure that we know this else here belongs to this if statement. This else here belongs to that if statement. So this is a good case to explain why we indent so we can visually see which statement belongs to whom. And else, you have another if statement. So under that else, right away, you have another if statement. So we indent that as a statement. Now, could I have put curly braces? Yes. And the only reason I'm not putting curly braces, it's because it's still considered one line. You will only execute one of these at a time. So if grade is greater or equal to 80, so that's my next condition, right? If that is true, all right, let's do 80.0 to be correct. Then printf, and let's use the same technique, %C /n. /n gives me a new line, and that would be the letter B. Right? So by now, you were less than 90, but definitely greater than 80, so or equal to 80. Then definitely you have a B. Else, if grade is greater or equal to 70.0, then printf, notice the indentation here, %C, and again, the letter C, else. Notice the else again, lined up with that if statement. You could see everything going in a diagonal. This is typical pattern in the text or in the editor whenever you're doing a nested if statement. And you could visually see which else belongs to which if statement. So this is why, again, it's important to indent to make sure that, so this will be another if statement here. And it will minimize the chances of errors. So greater or equal to 60 in our case, 60.0. If that is true, printf %C /n. This would be the letter D. Now we've reached the end of this. Else, no need for another if statement, just simply a printf. And %C /n. And that would be the letter grade F right there. Let me put a semicolon here. Now let's see what we have. Let me save all this. We have a bunch of nested if statements. And notice how it goes into a diagonal. It almost resembles what we're doing here in terms of the diagonal pattern here we have, right? So very similar. So as you can see, the last if statement, right, has either on the true side will be a D, on the false part will be a false. So let's look at the code again. The last if statement, greater or equal to 60, either have a D or have an F. Okay? All right, so all of this is considered block. So all of this is the true block of the first if statement that evaluated first for validity. Once the grade was valid, then we can get into the details of that particular valid grade. Now let's see how this works. So compile and run. Okay. Let's say this time we got a 78.5, right? Let's see if we get a C. And sure enough, we get a C. So I'm missing a /n for C. And you can see the press any key to continue is right next to it. So what I'm going to do is go back here, put a /n, give me a new line, and redo this. And compile and run again. And let's put that 78 or 77.6. We're going to get a C anyway. There you go. So you get a C in a new line. Okay. Now let's go ahead and run this again. And let's put minus 56. Now that's out of range, right? So minus 56 is invalid. Let's go ahead and test for an F. Okay, and I hope none of you get that. So 45 is an F. There you go. All right, let's go ahead and test for a D. Okay, that would be something like 67.4, and there you have it. Okay. All right, so the last test I'm going to do is a B. And that would be an 82.5. Let's see if we get a B. And sure enough, we do get a B. Okay, so it's always good to test all your possibilities when you have multiple if statements to make sure your logic is being driven into the code properly. Okay, so I hope on this you've kind of got an idea on how to translate an idea from a flowchart right here and map it to code. In the meantime, your learning objectives were if-then statement, if-then else, and nested if statements.